So in general, we define rational functions this way. We say that we have a rational function if your function is px divided by qx. Some expressions divided by other expressions, some other mathematical expressions. So as long as it's written this way, you have a rational function. And to find the domain is all real values such that with the condition that qx is not 0. Qx cannot be 0. So this is the general definition. Now take a look at this example. Suppose I give you reciprocal function. Consider a reciprocal function. So reciprocal function is 1 divided by x. Does it fit the definition of rational function? Yes, of course. Px is a constant. Q of x is just a linear expression. So what is the domain? Remember, when we're talking about a function, we talk about the domain, the graph of the function, and so on. So the domain, based on the definition, is the set of all real values such that the denominator is not 0. X cannot be 0. What's the meaning of that? It means that we can plug in any real value, real number, except 0. This is the problematic part. We are not allowed to use 0. Why? Because if I plug in 0, I end up seeing 1 divided by 0, which is not defined, undefined. So since you are not allowed to plug in 0, you have to exclude 0 from the domain. You can visualize the domain. You have your x-axis, 0, 1, 2, some positive numbers, some negative numbers. And remember, 0 is excluded. So you're going to use an open circle on top of 0. It means that 0 is excluded, and shade left-hand side and right-hand side of 0. You can also write domain negative infinity to 0, union 0 to positive infinity. I give you different format to write the domain of a rational function. So there's a situation here. In calculus, we say that 1 divided by 0 is infinity. So if I plug in 0 into the function, it's not defined. It is infinity. What does it give me? This shows that I have a vertical asymptote. Because of infinity, we say that at x equal to 0, we have a vertical asymptote. A vertical asymptote divides the graph into 2 pieces in this case. Take a look at the graph of this function. You need to feel comfortable about graph of these types of functions, guys. These are parent functions. Know the graph of this type of function. So if I plug in 1, it is 1. If I plug in 2, it is a half. If I plug in a half, it is 2, and so on. So one part of your graph is here on the right-hand side. The other part of the graph, if I plug in, for example, negative 1, 1 divided by negative 1 is negative 1. So negative 1 and negative. If I plug in negative 2, I get 1 over negative 2, which is going to be right here. If I plug in negative a half, I get negative 2 back. So So if I connect these points, this is the graph of this function. And remember that here you have line x equal to 0. Line x equal to 0 is nothing but your y-axis. So let me use a different color. Line x equal to 0 is y-axis. So what are you going to do? You're going to use dotted line, and you call this guy the vertical asymptote. A rational function, domain of a rational function, guys, you need to know this function, you need to know the name of this function, you need to know how to find the domain of this function, you need to feel comfortable about the graph and the vertical asymptote. Make sure to know this function. This is important. On the exam, if I ask you to write the reciprocal function and find its domain, you need to know the reciprocal function is 1 over x. And how we find the domain of that function.